In our last lecture, we talked about the atomic structure, and we talked about the fact that the atom is made up of subatomic particles called protons, which are positively charged, and they're in the nucleus. Neutrons, they have no charge, they're neutral, and they're also in the nucleus. And then electrons are negatively charged, and they surround the nucleus in those energy levels. And we talked about the fact that those energy levels can hold a certain number of electrons, and when they're full, they're going to be what we call stable. And if they're not full, they're going to be unstable, meaning they don't have enough electrons in that outer shell, and then they're going to need to get them from somewhere else. Excuse me. So let's today talk about a little more about atoms, but let's focus on something called elements. So there's all these different kinds of atoms that exist, but elements are what we consider a substance that can't be broken down into any smaller substances. So for example, oxygen gas is made up of O2. Oxygen is an element. So oxygen gas can be broken down smaller from O2 into just one single oxygen atom. So when a substance can't be broken down any further, that's when it's into its elements. And there's 90 naturally occurring elements in nature. So if you look at the periodic table, you'll see it goes above 90. It actually goes all the way up into the hundreds. And the reason why is because some of those are not naturally occurring. They were actually synthetic, meaning they were created in a lab, and they stayed stable long enough to be identified. But otherwise, they would not be found in nature. They're just made in a lab. All those elements you're going to find in the periodic table. So that's what we're going to be using a lot, actually. We're going to be getting a lot into the periodic table in this unit. Now, it's just something that I find very interesting. Think about your kitchen at home. Like imagine your house and your kitchen. You have a refrigerator. You probably have like a pantry somewhere where you have like your cereal and stuff like that. And then you might even have another fridge somewhere in the house. And then your basement, you probably have more food, right? So think about all the food in your house, right? Now let's think about the stuff that makes up the planet. And this is some interesting information to me. So we just talked about the fact that there's about 90 naturally occurring elements that make up matter, which still, that's not even that many. So if you think about the amount of ingredients in your house to make food, you probably have 90 different things there. So that's pretty much what the universe has to work with as well. Life, on the other hand, now this is where it gets even weirder. Only 25 elements are needed for life. So take that 90 and break it down even farther. So for a living thing, we only need 25 ingredients to make a living thing. Now let's take it even farther. Humans, us, 96%, okay, almost 100% of you, the physical stuff that makes you up, is actually made up of 4 elements: carbon, hydrogen, oxygen, and nitrogen. Those 4 elements are pretty much what you need for life. Now, having that said, there are other elements in there: sodium, potassium, magnesium, calcium. Those are all very important, but the 4, carbon, hydrogen, nitrogen, oxygen, that makes up 96%. So think about your kitchen again. Think about all the different things you have to make food in your house. Our bodies are made up of 4 ingredients, and that's it. So you might be saying to yourself, well, how is that possible? Well, if I take 4 ingredients, I can put them together a lot of different ways. And when you put them together different ways, they're going to react differently. So I just find that pretty interesting. What we're going to talk about today, though, is we're going to talk about that periodic table and how to use it to determine protons, neutrons, and electrons. So if you have a periodic table, you're going to want to probably get that out and take a look at it as I talk about what's going on. Okay, so the first thing you're going to notice in the periodic table is that there are 2 numbers with each letter. So if you take a look at the periodic table, this is carbon here. And carbon is the 6th element across the table, and that's why it has an atomic number of 6. So the atomic number is always going to be the top number, and it's always going to be the smaller of the 2 numbers. So you can see a 6 and a 12 here. The atomic number for carbon is 6. So what does that atomic number mean? Well, essentially, it's the number that's found above. So you're always going to see it above the symbol. So for carbon, it's above it. And it's always, always, always going to be equal to the number of protons. So what determines the atomic number is a very simple answer. It's the number of protons. And if it has 6 protons, its atomic number is 6. If it has 7 protons, its atomic number is going to be 7, and it's going to be nitrogen. So it's no longer carbon. So if you look at your periodic tables and you see 6, you'll see carbon. The next one up is nitrogen. And if I add another proton, it becomes oxygen. So as the number of protons changes, the actual element changes. So what makes an element what it is the number of protons. in an atom that is neutral, meaning it doesn't have a charge, it's not an ion, which we'll talk about later, that also means the atomic number is going to be equal to the number of electrons. So protons are positively charged, electrons are negatively charged. So if there's no charge on this, so for example, it doesn't say plus or minus next to the 6, that also tells us that it's the number of electrons. So the atomic number tells you the number of protons, and it also tells you the number of electrons as long as it's a neutral element or a neutral atom. And then finally, we have our atomic mass. The second number here at the bottom is what we call the atomic mass, and that is how much the mass of this atom is. So if I were to take this little tiny element and put it on a scale and we weighed it for its mass, that is its mass, but it's not in pounds, it's in something called AMU, or atomic mass units, and it's really used as a comparison. They're so small you can't actually weigh them. So this number represents AMU. But basically, the number below it is going to be the atomic mass. And the atomic mass is always going to be equal to the protons and the neutrons in the nucleus. So the protons and the neutrons together make up the atomic mass. Well, wait a second, Mr. Adolf. You're missing something, right? What about the electrons? I didn't mention the electrons. Why aren't the electrons also considered part of the atomic mass, right? If I want to weigh you and find out your mass, I'm going to take everything that makes you up. And protons, electrons, and neutrons all make up an atom. So why are electrons not part of the atomic mass? Well, here's why. Let's say you were weighing yourself on a scale and a little tiny fruit fly flew up and landed on your shoulder. Is that fruit fly going to affect the weight of you compared to the rest of your body on that scale? The answer to that question is no. That fruit fly is so small, the amount of mass it has is negligible compared to your whole body. Well, that is why atoms do not include the electrons in their atomic mass. Electrons exist, but they are so tiny that they hardly weigh anything at all. So we don't include them in the atomic mass. It's not that they don't exist, it's just that they're so small that they don't register. So the atomic mass is equal to the protons plus the neutrons, and that gives you the mass of the atom. So how do we determine the number of protons, electrons, and neutrons? So we're going to try this now, and then we'll hit the end of this little lecture. So the protons are always equal to the atomic number. Always, always, always. That never changes. And I'll go more into that later. So for example, a carbon's atomic number is 6, so it has 6 protons. The electrons are also equal to the atomic number as long as it's not a charged element. So for example, if it's a charged atom, that's not true. If it's a negatively charged, that means there's more electrons. If it's positively charged, there's less electrons. We'll talk more about that later. But if it doesn't have a charge next to it, they are also going to be the same as the number of protons. So if we're talking about carbon, it also has 6 electrons. And then finally, to find the number of neutrons, we just take the atomic mass and subtract the atomic number, because the atomic mass is equal to the protons plus the neutrons, and the atomic number is the number of protons. So if I subtract the 2, I end up with just the neutrons. For example, here I'll move my video again. For example, carbon has the atomic mass of 12, so I subtract 6 and I get 6 neutrons. So I'm going to go over some examples now. Okay, so let's get started. So if you take a look here, these are 2 elements, carbon and sodium. So we're going to do carbon first. We just did that example, but I just want to make sure we're all good. Okay, so the way I do this is I usually write out P equals, E equals, and N equals. So protons are positive, electrons are negative, and neutrons are neutral. So let's just do these 2, and then we'll see where everybody's at. Okay, so carbon, you can see this is carbon. It has 2 numbers, the atomic number up top and the atomic mass down here. Now, one thing I do want to point out to you, the atomic mass is 12.0107. We always are going to round the atomic mass. So if it's above 12.5, if it's above 0.5, you round up. If it's below 0.5, you round down. So 12.01 is going to be 12. Protons are always, 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 always equal to the atomic number. So there's going to be 6 protons in this atom. I know that because it's always going to be equal to the atomic number. That never changes. Electrons are also going to be equal to the atomic number as long as there's no charge over here. So if this said C minus 1 or C plus 1, well then that would be different, but it doesn't. So what we know is that the protons and the electrons are equal because the pluses and minus equal up. they cancel out, so we have 6 electrons. And then to find neutrons, we just take the atomic mass and subtract the atomic number, because the atomic mass is protons plus neutrons. The atomic number is protons, so we can figure that out by doing 12 minus 6 equals 6. So if I were to fill it in over here, I would have, if I use my little example, if I make these guys protons, I would have 6 protons, 3, 4, 5, and 6, right? And then I would have 6 neutrons. I'll make these blue guys here neutrons. They stay inside there. Just for the sake of speed, I'm going to we'll say that's 6. And then I have 6 electrons. So 2 go in the first ring, and then 4 go in the second ring. So if I were to ask you, is this a stable atom? The answer to this would actually be no, because it needs 4 more electrons to have that full outer ring. So let's just do sodium, just to see that everyone's on the same page, and we'll get going. So protons, electrons, and neutrons. Protons are always equal to the atomic number, so we're going to have 11. Electrons are also equal to the atomic number because there's no charge here, so that is also 11. And then sodium has an atomic mass of 22.99, so that's 23 minus 11, which is the atomic number, and we get 12. So it's going to have 11 protons, 11 electrons, and 12 neutrons. Thank you very much, and have a good day.